So we begin with chapter 7, internal forces and moments. Now we look at first the thrust in chapter 6. In chapter 6, we talk about thrust and internal forces of thrusters. So because in thrusters we have two force bodies. In two force bodies and straight two force bodies. We have straight two force bodies, and for example, we have AB and we have AD. To determine the forces in AB and AD, we cut AB and we cut up AD, right? We cut here and we cut here. So because this AB is a two force body, member AB is a two force body. It has only one force. This is tension, right? TAB. Is that okay? So in a two force body, we have only one force, and the force goes through the line connecting A and B. So this is for two force body, we have only TAB. Of course, the same goes with TAD. For TAD is of course, for TAD we have of course we have TAD, right? These are for trusses, and in trusses we have straight two force bodies. Each member is and in, for example, member AD, and this is a two force body. All forces act on 2 points. Two force body here, two force body there. So if in trusses we determine AB by cutting AB here and cutting AD here, right? We cut it off and then we determine the AB. We want to use this method on free force body. Okay. We say we have a point. This is a free force body, right? Free force body ABC, A, B, and C. And we cut it off at D. We cut it off at D, okay? ABC is a free force body. I'm sorry, let's go back. Do you want to copy this? I'll give you some time. Now we go on with free force body. We apply this method to free force body, and free force body here is ABC, and we have X and AY, we have CX and CY, and we have P. So this is a free force body because all external forces act on 3 points: A, B, and C. Now we want to determine. We use the method at point D. We cut off at point D. Okay. So what happens? First of all, we have First of all, we have a force here. Let me write it as F here. As in two force bodies. But it is not it's not the end of the story. We have more things to come. 还没结束哈。Can I write the problem is this. For AX and AY, can I draw it as something like this one? A parallel and A perpendicular. Can I draw it like this? Because in forces in X and Y direction can be written and in a parallel perpendicular direction as in chapter 2. In chapter 2. Like on page what? 1, 2, 3, 4, 5, 6, 7, 8. On page 8. Like forces can be written in the parallel and perpendicular direction. So let's go. So this is page 8. Okay. Let's say AX and AY is written in A parallel and A perpendicular. AX, AY, and becomes A perpendicular, parallel, A perpendicular. Is this part AD in equilibrium? Summation F equal to 0, summation M equal to 0. The answer is no. The answer is no at the moment. Because let me write it in the X prime and Y prime directions. X prime and Y prime directions. Summation F in Y prime direction is equal to A perpendicular. And it is not equal to 0. Okay. So if we only look at this, that and we say this is X prime direction and Y prime direction, we take in the force in Y prime direction is only A perpendicular, and this is not equal to 0. Okay, that's problem 1. And problem 2, summation M equal to 0. What is summation M here? Let's say we have point D here. Let's say we take a look at point D. And this length is equal to L. So MD is equal to minus L times A perpendicular, which is also non-zero. So what should we do? What should we do? For free force bodies or like a curve, for two force bodies that are not straight, we need to add something. we need to add something like called shearing force V and bending moment M. Okay. For free force bodies or non-straight two force bodies. So if we use the method for trusses, for example, cut this free force body at P. Of course, we need F here. We need F here on this axis, but we also need one force P perpendicular to F and one M here. So let me write it down here. And Fy prime is equal to A perpendicular plus B. And MD is equal, summation MD is equal to L minus L A perpendicular times M. So this one is called V is called shearing force. And bending moment 1G. So we need to take in these two, we need to add two additional forces. I'm sorry. We need to add two additional forces if it is not a two force body. So just give you a taste of what things look like. For bending moments, if there is M here, I'm sorry. If we have bending moments, say M here. So usually bending moments means rotation, right? And we have a pin joint. Let's say we have a pin joint, or we have a fixed joint here. If we have a fixed support here, what does M? What would M lead to? 会导致什么？ It's called bending moment, 1G. So it is with M, this rod will bend. Okay. So you will learn this in mechanics of materials next year.